the arah ialah negative. So you must know where is in, where is out. Jangan hafal color coding. Because the tubing is green and orange, betul? So sometimes customer saya kata, oh orange kat sini ya, hijau kat sini. Jangan, tubing itu boleh mana-mana arah. So but the one that you need to belajar ialah dia punya anti-clockwise. So know where is inlet, where is outlet. Okay? So peristaltic pump will taking the sample in. So then after your peristaltic pump, the first thing your sample contact is your nebulizer. So this nebulizer is the one that going to clog. If your urine got a lot of particles, yeah. So I think hari tu bila dia urine project buat lebih kurang 2,000 sampel, then they clog. So kita punya engineer bawa tools untuk cuci kan. Lepas tu mereka beli. So hari ni saya pun bawa, saya takut you akan block clog kan. Sometimes sample food you selepas microwave you filter your sample then lebih baik. So like this is a nebulizer. So the concept of nebulizer is like that. Sample going into the capillary, okay, through the capillary, and then your argon gas is blowing in this way. So this argon gas, or we call them nebulizer gas. Okay, because when you use argon gas as a nebulizer, we call it as a nebulizer gas. So nebulizer gas will blow at the outside. So what happened is, in this hujung, if I want to zoom it out, so in the hujung tip ini, so if I want to draw bigger image, it will be like this. So argon gas is blowing this way, blowing this way. So it's going to create a donut of low pressure. Sample is at the capillary, so argon gas is blowing outside of this ring. Yeah? So now this zone will be going to be the low pressure zone. So now I cramp myself in the capillary, is so compact. So but outside layer is all the low pressure. What happened? The liquid will draw 360 degree. Okay, when the liquid being drawn 360 degree, hit by the argon gas, then selepas itu dia akan keluar aerosol. So this is how your nebulizer work. So from liquid here, your sample is actually in liquid. Your argon gas is blowing, create a low pressure zone. So when the low pressure zone is being notified by the sample that in the capillary, all the sample kata, oh sana low pressure. So they will all go 360 degree, hit by the continuous flow of the argon gas, then it become aerosol. Okay? So now after your nebulizer, then this is your spray chamber, where now I put into the cyclonic spray chamber. I put into the sonicate. So what happened is, your spray chamber will be the one that, so I'm going to draw like that. You have to draw this way. So your creation of the aerosol actually will be big and small droplet. So what we do is we're going to use cyclonic. Cyclonic is going to use a centrifuge way. So the sample will be pushed by the nebulizer gas, and then it become aerosol, tapi ada besar, ada kecil. So now you nak separate. Yang besar punya titisan go to the waste. Then only the kecil punya, we want it to, kita akan what will come them to go into your injector. Remember just now I show you like that. Then this is your injector. So we only welcome those small droplets into the injector. Okay. So how they are going to centrifuge? When the moment they centrifuge, big droplet akan dekat luar. When they dekat luar, they hit at the dinding on the spray chamber, then dia akan meleleh-leleh. When they hit at the wall, they actually akan meleleh keluar. So that's why this is the waste. So then your fine aerosol will be going to the injector. So this just now I put into the beaker, is the plastic beaker is spray chamber, but this one you cannot sonicate because capillary, if you sonicate, habis. So that's why you have a tool, have an eco cleaner tool for the nebulizer. So now you put it in the spray chamber for sonicate, and then injector also sonicate. Then here will be your torch. Okay, so now I'm going to draw your torch. So actually your torch have two layers. Your plasma, this is kaki into plasma, then this kaki into auxiliary gas. Yeah? So actually it's like that. So they work like this. So now, whenever you work as a plasma gas, will be like this to create this plasma. Maybe I want to ask you, You all know what is plasma? Plasma actually is a zone that is highly energized. So energized is because you using argon gas, you take your raw material is argon gas, and then because you have the RF generator here, RF, you have the loop coil here, so you actually created this called plasma. When I say plasma is this. So plasma is actually highly energized and energy, highly energized gas.
Argon.
Ion, and then it's ionized. It contains same amount of ion and same amount of charge positive and charge negative in the aliran here. So meaning to say aliran means it never stop. You tak apa aliran, aliran sungai itu tak pernah berhenti. So the moment you turn on the plasma, plasma is like that. Okay. So and then they have a lot of energy. So this is your bank. So this is your bank. How it works actually. So now, maybe I tell you again. So we also have a auxiliary gas. This is a plasma. Just now when we letak buka kaki dia, this is a P, this is A. So your auxiliary gas is here. So because this is your torch and then this is your injector, so you want this temperature of the plasma is very hot. So the temperature of plasma is about 10,000 Kelvin. So it's so hot, you don't want the bullet of plasma to touch your torch. So that when you touch your torch and touch your injector, and then your injector and torch will melt. So your auxiliary gas actually is a cell-protective gas. Okay, so now let's move in further. So you already know plasma is actually aliran, highly ionized gases, contain same amount of charge positive and charge negative, and then they have a lot of energy. They have a lot of energy to donate out. So now your sample inject into the plasma. So what is the process when your sample inject into the plasma? So I'm going to go here. Actually, your sample is still in liquid, right? Because you mark up in the IA. So even it's the titisan IA, it's still got water. So whatever you want to run, arsenic, cadmium, mercury, normally they will combine with another ionic. So then they also have water because they are in the titisan IA. So the moment they inject into the plasma, because temperature of plasma is very hot, so the first thing plasma do is actually dry out. Dry out your sample. Now your sample become like that. Okay, and now this one is already become dry, become solid. So then later on, in the plasma, also plasma will make it to become gas. So that means dia tak ada phase or liquid. Normally kita kata pepejah, cecair and gas kan. So they did not go through liquid phase. So they from solid they go to gas. Okay, but this is still gas molecule, cannot yet. So what the temperature of plasma do is, plasma is going to help us to break everything to become singly free atom. Okay, wherever you want to run analysis, everything from AS, ICP-OES and ICP-MS, everybody must go to become free atom first before they want to draw the energy from this bank. Okay, so once I become free atom, what I do is I'm going to draw the energy from the plasma. So plasma got how much of energy? Plasma have 15.2 atau 0.4 electron voltage. So if you run analysis, you need energy lesser than this, you can run. So only element have energy potential more than this, then you cannot run with the other plasma. So all periodic table, every element can be run by ICP. So now when I draw the energy is when the sample I become free atom. Normally this process is like that. This is all the pre-production. So your sample already become free atom actually as this zone. If I draw, this is a zone you become free atom. So now when you become free atom, this is the moment you're going to collide with the plasma. This seed of plasma. So this plasma will collide dengan you. What happened will be the moment I collide, this plasma a lot of energy will transfer the energy to the free atom here. So to your cadmium, to your lead, to your mercury. So once they receive the energy from plasma, then they become singly charged ion. ICP-MS must have a singly charged ion. Okay? So now I just tell you the sample introduction. So by right, after this is your gate. So this is your, kita belum lap lagi, tadi kita cuci sample introduction. Nanti we go to the ICP, we going to lap the cone, we going to cuci sample cone. Then we going to cuci, then another cone is skimmer cone. Then another cone actually hyper skimmer cone, right? So this is all the sample introduction. So maksudnya by the hujung of your bullet of the plasma, by right you already ready all your M plus. Okay, so if you don't ready your M plus, you cannot run analysis because after that is your quarter pole. If you don't have charge, quarter pole will kick you out from the system. It will go to the vacuum pump. Okay, so you must create the single charge, and this is the beginning of the ICP-MS. Okay, okay. Alright, so now I'm going to wrap off. I'm going to draw your quarter pole. Yeah, I'm going to draw your ICP-MS.